Industrial Revolution. Do you like that? What? The Industrial Revolution. That was fun.
That was fun.
All right. I guess I heard it was fun.
About like the age of imperialism and stuff like that.
All right.
And they went into Congo.
History is pretty fascinating. I like going to museums and stuff like that. Anyways, history of the atom. Who's the first person to talk about it? That guy. Democritus, 460 BC, almost 2,500 years ago. Long time ago. Then not till what, 1808? Who was it?
John Dalton.
18 what?
1808.
It was 1808. John Dalton, right. And after Dalton, J.J. Thomson. What did he discover?
That sounds like a rapper.
J.J. Thomson, that's right. What? Electrons. Right, he discovered the electron. I'm going to show you the experiment that they did today. So J.J. Thomson discovered the electron. What else did he come up with? The first model. What was it, Evan? Plum pudding, right. And we drew that yesterday where we had a circle, right? And that circle is like the bowl of pudding, and that was positively charged, and then the negative electrons were stuck in the pudding. Those were the plums. So that was J.J. Thomson. After that? Yeah, Ernest Rutherford did the gold foil experiment. We wrote down two things from the video. What two things did he prove about the atom? Good, that there was a nucleus. What else? Had a positive charge. Why is it positive? Why is the nucleus positive? Because of what's in it. What's inside it? Protons. I want to make this clear. A proton, you don't have to write this, you can just watch. Proton is 1/1h. An electron, which are not inside the nucleus, right? Electrons, 0/1e. That's an electron, right? So inside our nucleus, you have a bunch of positive signs and zeros, meaning neutrons. And outside, we have the electrons, okay? So I want to make it very clear. Rutherford proved there was a nucleus and it was positive. So let's forget that for a second. Let's fast forward now. Now we know that the protons have to equal the electrons. Here's why. The magnitude of the charge, this was just like that multiple choice we did yesterday in the beginning of class, the magnitude is 1 for both of them. So that means the number 1 is the same, right? It's the same size charge. However, protons are positive, electrons are negative. So these two particles in terms of charges, Jake, you with me? Okay. These two particles in terms of charges cancel each other out. So for every one proton, there's an electron. And if you have the same number of protons and electrons in an atom, the atom is electrically neutral. Everything in this room is neutral. If I touch this table, this marker, the marbles here, this banana, whatever I touch, I don't get a shock because I'm neutral and everything in this room is neutral. This is why. The number of protons inside the nucleus always equal the number of electrons outside if the atom, my voice is like all messed up, sorry. If the atom is neutral, and 99% of the time atoms are neutral. The only way an atom is not neutral is if we start getting rid of electrons or adding more electrons. So we can either take electrons from atoms or give atoms electrons, so that disrupts the balance. But for your purposes, whenever you look at the periodic table up there or in your reference tables, if you look at the atomic number, that atomic number tells us the number of protons for sure. That never changes. It also tells us the electrons if it's neutral. Again, for your purposes, we assume it is neutral unless otherwise told. So we always assume they're equal unless we're told differently. Why is my question before we continue reviewing the history there. Why are the protons never changing? How come we can never change the number of protons? In other words, if we look over on the side here, why is carbon always number 6? Why is oxygen always number 8? Why is sulfur always... How come they can't change? How come I can't give nitrogen 1 proton? Why? Why can't it lose a proton? What if, over here, lithium gained 1 proton? It cannot do that, but let's say magically we did it. What would happen to lithium if we gave it 1 more proton?
Wouldn't it not be lithium?
It would not be lithium anymore. What would it be? Beryllium. That's impossible. Have you ever heard of alchemy? alchemists?
Yeah,
They
when
tried to
try and
turn
make
lead into
lead
gold. Lead right here.
I did that.
Lead 82 protons. Gold has 79. So a lot of ancient chemists tried to strip lead of 3 protons and turn it into 79. I mean, that's what they were trying to do. They didn't realize what they were doing because they didn't really know everything at the time. But you can't do that. It's impossible. You can't turn one element into another.
I did it.
Nuclear.
In my backyard.
Okay. Nuclear chemistry alters the nucleus. That's why it's called nuclear chemistry. But in nuclear chemistry, you can't simply take carbon and turn it into oxygen. It doesn't work that way. When we learn nuclear, you'll understand a little better, I think, I hope. But you can't turn one element into another. And here's my next question. Why? Why can't we alter the number of protons?
Is it because it's in the nucleus?
Because it's in the nucleus. Very good. What holds the nucleus together? The strong force. That's why. You can't mess with it. It's too strong. You can't get anything in, you can't get anything out. The only way you can mess with that nucleus is if you smash that with a particle accelerator, and that creates basically a nuclear explosion. And guess what? You're not creating a new element on the chart necessarily. You create energy and all these unstable particles that don't exist very long. So you can't just take an element and turn it into something else by adding a proton or taking it out, because the nucleus, I say, is like a bunker. It's in there. Nothing's getting in, nothing's getting out. Okay? Where are the electrons? Outside. So they can move around, they can buzz around, they can pop right off easily. You can just take one away, you can add one. That's because there's more movement, more motion, freedom, if you want to think of it that way. But the protons are on lockdown. You can't get in there, you can't get them out. All right? So that's really important to remember. I'm not going to write it down. I'll talk about it a lot. Proton always stays the same. So anyways, Rutherford said, all right, the nucleus is positive. Later they figured out why, because protons are positive. He also proved 2 other things. Well, what's the other thing we wrote down? You said it has a nucleus. Oh, and it's positively charged. The other 2 things Rutherford proved: all the mass of the atom is in the nucleus. All the mass is inside that nucleus. We'll talk more about that next week. And then what he also said was the rest of the atom was empty space. So this area where the electrons are buzzing around, he said, is empty space. So that's the other things Rutherford proved. We'll write that down next week. Who came after Rutherford?
I can finish like 3 problems because I
All right, so you have, when can we do that?
I can come in like 2 periods.
Okay. Who was after Rutherford?
Niels Bohr.
Bohr, right. And the Bohr model, what did Bohr say? What did Bohr say? It's so dry.
He said that the electrons were orbiting.
Yeah, right, but they're not.
Orbitals.
Right, good.
Which doesn't
Bohr,
make any sense.
So-
It sounds like orbiting.
we're going to come back to that. So Bohr said we have these levels. How many levels are there? 7. So Bohr, I only drew 4. There's 3 more, right? So 1, 2, 3, 4. You guys have this drawn, right? Okay, I'm going to add something to it. So hopefully you have room. I just want you to put first, second, third, fourth. And then I want to add how many electrons, because that's what he was correct about. They do not... Where you go?
That's me. I don't feel like they'd be out there fine.
That's on camera. It's fine.
Well,
It's awesome. So I'm just
They
gonna
interrupt class.
yeah, like multiple times. Appreciate it.
I know, I didn't
I'm
want
just
it.
joking with you. All right, it is 11:40. There you go.
Thank you.
Okay. All right. So, yeah, he was correct with the levels, but they do not orbit. They do not orbit. We'll talk about the orbitals in a couple minutes. However, he was correct with how many electrons are on each level. We went through it yesterday. Who remembers? How many electrons on that first level? 2. Put 2E minus right on that line. How many electrons on the second energy level?
You can't rate this.
Or second shell? 8. Elf on the shelf. What about the third? How many electrons on the third? 18. What about the fourth? 32. 32. And then the fifth, sixth, and seventh also have 32. So the bigger the atom, the more electrons, which means the levels get bigger, means they can hold more electrons. So Bohr was correct. I honestly don't know, I'll admit. I don't know if he discovered or determined the actual number. Probably not. That's probably much later. But he knew there was a set number. So that's the Bohr model, which is very helpful for visualizing, but it's not exactly how it looks. In lab, I'm going to show you guys, well, today I'll show you the current model, but it's really confusing, so I'll show you something else in lab that may help or may make it worse. We'll see. And then AP Chem, you got to really know.
Just wing it.
So, what's the most current model? Or no, yeah, after Bohr, that was it, right? That was the last person we wrote. Okay.
And you wrote down current model.
Yeah, the current model. But I want to give credit to two other guys, R.A. Millikan and James Chadwick. You don't have to write this. I just feel the need to explain it. Millikan did something called the oil drop. He dropped little droplets of oil and shot the oil with X-rays as he suspended them between electromagnetic field, a magnetic field. Sounds really complicated and weird. Basically what he proved was the charge of an electron was a certain charge, like an actual number in coulombs, which is more physics. And he also found the mass of an electron, which is ridiculously small. We'll be talking about that next week a little bit. So Millikan did that, and then Chadwick helped with protons and neutrons, like discovering them, figuring them out. So I just gotta give them a little shout out there.
Do you like
Now,
physics?
do I like physics? Yeah, it's some of it's pretty hard, but I do like it. Yeah. A lot of this stuff we're talking about, chemistry ends, physics picks up. The new current model is almost all physics. All right. So, who were the two scientists that contributed a lot to the new model? We wrote it down. We should have. Did we not? The two scientists contributed to the new Heisenberg and Schrodinger. Right. What's the three names of the new model? Wave mechanical. Quantum mechanical.
We should just use only that one because it sounds cool.
Quantum mechanical model and the electron cloud. Quantum means what? Anybody know? You guys ever hear of a show called Quantum Leap?
No.
There's usually someone. So it was my favorite show by far, which is not weird because it's related to science. So I guess that's not weird. At the time I didn't know, but I thought it was cool. Let me tell you about the show. The main character's name was Sam Beckett. What's his real name? I can't believe I can't remember his name. He's now an actor on CSI New York, which I don't watch, but I see commercials. Anyways, I think it's CSI New York. No, it's CSI New Orleans, whatever show that is. Anyways, what's his
They
name?
have in New Orleans? I thought there was only NCIS in New Orleans. Are you sure?
What is it called?
NCIS New Orleans?
Oh, that's it. Sorry.
Which one is he?
NCIS.
I was watching that last
The
night.
NC, that one.
Yeah, which guy is he? He got black hair and a southern accent?
I've never seen the show. I just see commercials.
Is he the old guy with gray hair?
Well, yeah, he's not that old. I don't know how old. He's probably in his 50s.
Yeah, then he's the old guy.
There's not, okay. Man, I guess I'm getting older. Someone who's 50, I don't think is like an old man, but.
No, he's just.
Well,
he
he's the
has
oldest
gray
guy.
He's the
hair.
oldest dude on there? Alright. So, yeah, him. He's in Quantum Leap. Anyways, he's a physicist, some super smart physicist who discovers a way to, like, time travel. But it's called a quantum leap. And it's actually relevant to what we're learning. That's why I'm talking about it. So, his body, like, gets all energized, and something happens to his particles in his body where he turns into someone else. So he leaps into
This
their
is
body.
Mumbo Jumbo.
Yeah, it's nonsense, but it was awesome. It was an awesome show. So every show, he would like wake up in someone else's body. So he would like get frozen, his whole body would turn like white, and all these like lightning things would shoot out, and then he would like wake up in a different body. And sometimes he would
Did
wake
he
up.
ever wake up as a president? Oh,
Yes,
that'd be
I
sick.
think once he was. I think,
That would
but
be
he
sick.
woke up as
Like president for the-
a
go to
female a
the
few
world
times, so
and
that was
button.
interesting. My favorite one was he leaped into a boxer right in the middle of the match. So whenever he leaps in, he has no idea what's going on. He doesn't know what year it is because it's all over, and so he like was like, looking around. The guy knocked him out. So that was funny. There was other ones too. There was one he was like in a professional baseball player, and he just leaped in when he was about to swing and he struck out and he was a big loser or whatever. So that was cool. It was entertaining. Anyways, what does that have to do with this? Quantum leap. There's a lot of science behind the term quantum leap. Quantum means energy. Leap. What do you think of leap?
Leapfrog.
Jumping, right? Yes, leapfrog, jumping. So what happens, the word quantum means energy or bundles of energy. I don't know why I erased that. You got your nucleus, and then here's your energy levels. What a quantum leap is, if an electron from here jumps up to a higher energy level, that's called a quantum leap. That's a real thing and exists in real life. The show obviously
That just made your show so boring. You don't even realize.
The show was awesome.
The show was.
YouTube that
The show was awesome until you just explained that.
The beginning of it and the way they it's funny. Anyways, the music and everything. I don't know. I was a kid, so you like things when you're a kid. Back to this. We're gonna call it wave mechanical. That's the most common, but I might call it quantum mechanical sometimes.
I like quantum mechanical.
Okay, electron cloud. Think of a cloud. So what happens here is you have your little tiny nucleus, and then you have dots that represent what? What do these dots represent? Electrons. I'm going to show you a better version online here in a minute. That's the most current model. Okay. However, these dots aren't completely random. These dots, these electrons, are confined to tiny little spaces called orbitals. Yes. You can. Orbitals. Okay? So orbitals are these little regions of space that the electrons are confined to, which is why electrons don't, I almost answered a question I want you to answer. I'm going to stop. So let me show you this, and then we're going to come back to our notes. I want to write down a little bit more about this, okay? Let me write that first, then I'll show you that. All right, so underneath this, or wherever you have room, we're talking about this model, okay? Put a little star here. Electrons. So this was the biggest thing with the new model, is there's more information about where electrons are and what they're doing. So electrons are found in regions of space called orbitals. So that's where electrons are found. So not only are they on, I'm putting orbitals in quotes because, I don't know, I just want it to stick out. It has nothing to do with orbiting. That's the part that's frustrating, I know that. But they're called orbitals. And besides the levels, they're inside a certain space that's called the orbital. So they're you know, kind of like you live on a street, but you have a specific address to your house or apartment or whatever. So like the level is the street, right? And then the orbital would be like your house. So there are these levels, but then they're confined. The other way I explain this concept is I call it the electron hotel. So like the levels are like levels or floors in a hotel, and then the hallways and then the rooms, like you're in now a room, is also another analogy for an orbital, okay? We can use school as an example too. So the last thing I want to write, and then I'll show you some stuff, if you want to find a student right now, you would move or you would go to a classroom. That makes the most sense. You might find one in the hallway, but there's more students, should be, more students in classrooms than in the hallway. There's something we have to write here about that. And this is the science behind it that I'm confused with. Heisenberg and Schrodinger use all types of fancy math to actually come up with the shape of an orbital. There's 4 different orbital shapes, and the shapes are based on wave functions, which is pretty advanced math that I don't really get. So in other words, imagine it's a 3-dimensional space, but it's defined by mathematical equations. So if I was to build a box with wood or a cardboard, you know, whatever, you have an actual physical box that's made with wood, made with materials I can touch and feel, whatever. This has a shape you can't touch, feel. It's not made with anything concrete. It's created based on mathematical equations. Right, Evan? Your mind's blown? My mind just melted. My mind just melted.
So what are they trying to like make an equation for? Like a magnetic force around it or something?
Sort of. It based on they somehow can figure out how the energies and how the electron can move around, and based on these mathematical wave function, they can figure out what that space looks like based on the electron movement. So in other words, the electron in this orbital doesn't move like this, because that would be kind of like a cross type shape. It moves in a circular pattern. So the orbital is kind of like a circle. But there's math to prove it. I don't fully get it, I admit. So, last thing we're going to put with this. Write this down. The highest probability of finding, there it is again, an electron. Finding an electron, the highest probability of finding an electron is in an orbital. This is kind of like one of those you just smack yourself in the head. Yeah, of course. But maybe you don't think that. I don't know. I guess what I'm saying to you is if we know electrons are in orbitals and you want to find one, the best chance of finding one is looking in an orbital. Makes sense, but this is actually kind of like the definition of the Heisenberg uncertainty principle. So this new wave mechanical model, I'm really trying not to confuse you, but the wave mechanical model is all about this. The orbitals and the highest probability of finding them are in orbitals. I'm not going to get a chance to show you, am I? I'll try. I guess you have my homework.
Yay.
Apple pie or pumpkin pie?
Pumpkin pie.
Or neither?
Both, you dummies.
Wait. If
Oh.
there's like, if you could do like coconut cream.
If you have to do one or the other, apple or pumpkin.
You must do all.
Pumpkin either. Pumpkin any day.
Lime pie.
It really depends on
pie,
how good the pumpkin is.
lemon pie,
I'm going
chocolate
pumpkin.
pie.
Can't go wrong.
No,
Yeah,
'cause
you
apple
can't go wrong.
pie.
I've had
Pumpkin pie
sour
really
apple
have
pie.
really good pumpkin pie.
So like they made it with like Granny
No,
Smith,
pumpkin pie is.
and I did not like that.
Pumpkin pie only have like 5.
I've had too many apple pies lately, so
Pumpkin pie, I can sit there and eat the whole pie. I don't cut it up into things.
Bro,
Eat it
hit the
like
lights.
you're eating like
I think I have a little bit of
I
time,
just eat it
maybe
like
not.
that, with whipped cream and ice cream mixed into it.
Don't you rest on it? Isn't that not good?
Nothing.
Roll that all.
You're not supposed to. You're just supposed to.
Those are the wave functions.
This does not do anything.